So, today we will demonstrate how to measure the focal length of convex mirror. So, in last class I have shown you how to measure the focal length of a concave mirror. So, today we will do the same things for convex mirror, right. So, measurement of convex mirror, focal length of a convex mirror, right. So, working principle is basically not same as the uh, concave mirror. So, in concave mirror we get the real and inverted image, but for convex mirror all the time we get the virtual image. Concave mirror, of course, if the object distance is less than focal length, then only we get the virtual image. Otherwise, when object distance is greater than f, then all the time we get the inverted uh, real image. Okay. So, that means real image we can actually put on the screen, we can see the real image on a screen, but virtual image we cannot put on the screen. So, measuring the image distance is difficult if you cannot put the image on a screen. So, that is why directly we cannot measure the focal length of a convex mirror as we are able to do for the concave mirror. So, that is why this method is basically indirect method, and for concave that was the direct method. Okay. So, for this case, taking help of convex lens, we can find out the focal length of the convex mirror. Okay. So, now look at the diagram. So, in this diagram, there is a lens, convex lens, right. There is a mirror, okay. And here this is the object needle, this is the object needle, O object needle. Okay. Now, here is the image, inverted real image. How we are getting this image? Say, so this from the tip of the needle rays are going and refracted or converge the light, after the lens, okay, converging the light from the lens, right. Now, if mirror is not there, so this ray will go and meet at this point. So, that means due to this lens we will get the image at this point. Okay. So, you know this for convex lens we will get the real inverted image, okay, real inverted image, right. Now, due to the lens, when this object is here, object is generally object distance is greater than focal length of this one. Okay, it is between f and 2f generally we keep. Okay, then we will get the inverted real image, and that is the position at this place. Okay. Now without mirror, basically then this is the object needle. So image needle I can put here, using the parallax method. I can find the position of the image as I have shown you during the measurement of the focal length of the concave mirror. So that same way one has to find out the position of the image using the image needle, right. We have to just remove the parallax, okay, then that position will be the. So today also I will show you. So this is without the mirror, only because of the lens. Now if I put a lens between if we put the mirror, convex mirrors, okay, after the lens, okay, then if I just move this mirror to and fro, then and look image. So there is no function of this one. Now I cannot see this one, right. So now it's a mirror here. So I have to see the image from this side, okay. Earlier I was seeing the image from this side, now I have to see the image from this side, okay, because light will be this light, it will not reach here. So that's why I have put it here dotted line. So now light will be reflected from this mirror and they will come back, okay, and either they will this reflected rays from this mirror, they will form the image either virtual or real, depending on the angle of the refraction, whether it is diverging or converging, okay, generally is diverge. So now think that if I try to find out the image at this place where the object is there, if I try to find out the image at the same place where object is there, and for getting that one, if I just adjust the position of the mirror, and I will get a certain position, I will get a particular position where for that position I will get the image exactly on the object. How it is possible? It is possible only when the light will come back following the same path, okay. Light was going out from this, and in same place I will get image if I get the reflected light in same path, okay. So it will trace back, tracing the same path. When it is possible? When light will fall on the mirror perpendicularly, right. Only then it is possible to retrace, come back with the following the same path. So for this position of the mirror, when I am getting the image at the same place of the object, right, then I can think that the light from each point on the mirror, so they are falling normally on the mirror and they are coming back. Okay. it is possible only when, if you, this is the center of curvature of the mirror, okay, right. So, as if from center of curvature, this all line if you draw, so they are perpendicular on the mirror, because they are the radius of curvature, right. So, they are perpendicular on the mirror. So, if light falls along this line, that means it is falling perpendicularly. So, it will reflected back following the same path. Okay. Now, of course, in lens, always the reversibility is all the time, it follows the reversibility. If incident light is this and this refracted this, if you reverse it, incident light is this, then refracted will be the other one. So, it follows the reversibility. Okay. So, from here it is clear that if you find out the proper position of the mirror, so that you are getting the image on the same place of the object, then this mirror basically center of the mirror will be that one where we got the image of the image from the lens of that object. Okay. So, here this position here I have in absence of mirror. If mirror just if you take out, so this is the image position. Now, if you put mirror here, okay, so image position will be, so adjusting the position of the mirror, you will get a particular position when you will get the image position here. Okay. So, in presence of the mirror, image you will get here. Okay. So, in this practical, what I have to do? Actually, I have to find out the position without mirror. I have to find out the position of the image of the object due to the lens. Okay, this I have to note down, and then without disturbing object and the lens, now I have to put mirror here and find out the position of the mirror, so that I am getting the image on top of it. Okay. Then I have to note down this position of this mirror. So, now this distance mirror to this image, lens image distance, that is nothing but the radius of curvature of the mirror. So, focal length will be r/2. So, I have to note down only this two position. Okay. So, I think I have a table, data for focal length of convex mirror. So, position of convex mirror I have to note down, and image needle, position of the image needle I have to note down, right. If you note down these two position, so pi, that whatever difference of these two position will give basically radius of curvature. So, you can take 3 readings. Okay. Just adjusting the mirror position. Okay. You can take 3 readings and find out the mean of this r, and from there you can find out the focal length. Or you can do the 3 sets of experiment. You can do 3 sets of experiment. Just one experiment you are doing for a particular position of the object. Okay. Now, just second set you can take this, just change the object position by 2 centimeters. or plus minus 2 centimeter, 2 more sets of reading you can take, and then basically you have to find out the focal length for each case or mean uh, radius of curvature. So, from there you can find out the focal length. Okay. So, that is the experiment. So, remember this sequence. First, without mirror, I have to find out the position of the image due to the lens, and then I will put lens mirrors, concave mirror, convex mirror, and I will try to find out the position of the mirror to get the image on top of it. Okay. So, unfortunately, in camera I cannot show this coincidence and this parallax method, but I will show the step how to do the experiment. Okay. So, this is the same optical table as last time we have used, right. So, this the mirror, this is the mirror, convex mirror, right. We want to measure the focal length of this convex mirror. Okay. So, let me keep it here. Let me keep it here. Now, this is the lens, convex lens. Okay. So, and this is the one needle. So, say this is the object needle, and another needle I need to get the position of the image. So, this is the image needle. Okay. So, put this convex lens in the table. So, to make it, I think I will. So, this focal length actually of this lens is approximately, it's we know this is around 20. If it is better to know the approximate focal length of this of the lens or mirror. So, then you can do your experiment. So, here that how to find out again, you can see if it is within the F. So, you will get the image of this needle, object needle, as a virtual image, and it is an erect one. Okay. Now, if you change the position of the lens, and then when you will cross the F, okay, so then you will see that it is becoming inverted. So, during the changing from erect to the inverted, so there you can approximately you can guess that its wavelength, this focal length is what is the magnitude that you can find out. So, in this case, I think this one has to be careful, because anyway, let it be there. So, I can see now, I think I will remove this one. Let me see the image of the, yes, I can see inverted image. So, to guess the, yes, now I can see this very, I can see the erect image of this one. So, that means its focal length is greater than, now it is at position of 20 and its position is 36, that means 16. Okay. So, that means its focal length is greater than 16. So, it is then if I take just increase and then increase, is it's becoming started to be inverted. Okay. So, what is the position? So, here I can see this is 46. So, 20 and 46, 25. So, its focal length is around 20, 20, around 20, 25 in that region. Okay. So, I have to keep this lens position greater than focal length. So, this is the approximately position for the focal length. So, I will keep it at the higher distance than this position, and I will see the inverted image. I will see the inverted image. Yes, I can see the inverted image. So, I can see the inverted image. So, I am keeping approximately, say it is around this distance 20, I would like to keep at 50, okay, around this 30 difference. If this focal length of this one is 20 or between 20 25. So, I kept it as 50, it is at 20, that means this distance is object distance is 30 greater than focal length. So, now for this position I will try to find out the image. Yes, I can see clearly image position. So, for that image needle I have to use, okay, and parallax method. So, I can see the clearly I can see the, yes, I closed my left eyes and seeing through the right eye, okay, I can see. So, I have to yes, decrease the, so to tip of this image and tip of the, first I have to try to make it coincide, tip of the image and tip of the, yes, it's coincide, it's I think slightly up I will take, yes, yes. So now I can see that both tip coincide. Now I have to remove the parallax. Okay. I think I have to fix it, and then yes, both tip at this position. Now slide. Yes, so this position I found, this position I found that this tip of the image and tip of this object image needle, they coincide, and this parallax that is also removed for this position. So now I have to note down this position of this image, right? I have to note down the position of this I think. So position of the convex mirror and image needle. Okay. Now image needle, this one. So this is say 107. So I will write 107. approximately 107, actually I can say 106.8, 106.8 centimeters. Okay. So I have to write. Now what I have to do, without disturbing them, I have to put these mirrors. Okay. I have to put this mirror, and now I have to find out the position of the mirror so that I can see the image. I can see the image at this position, at the object position. So that means from the object where the light going, so reflected one will come, will retrace the same path. It will retrace the same path only when it will be reflected from the mirrors. It will perpendicularly, or the incident rays will fall on the mirror perpendicularly, and then it will be reflected also perpendicularly, right. So then image and object will be in same position. So now I can see the yes, I can see the image. So I have to adjust the position of the mirror. I have to, yes, I can see. So I have to find out the position where I can, so this image will coincide with the tip of this object one. Slightly away, I should see. Yes, yes, I can see image, but it's not coincide. So I think slightly more. Yes. I can get, this is the position where looks to me is that, yes, coincide slightly more. I have to take. No, no, yes, no, it is separated. Yes, so I can see it's coincide with this, with the tip of the object and the tip of the image on the same line. Then also one should see the parallax, but still slight parallax is there. Slight parallax is there. No. No. So I have to come closer. Yes. Let me check. Yes, slightly move. Yes. Oh, slightly more. Yes. Slightly more. I come and see. No, I have to go other way, slightly. Now it's nice. So there is no parallax. Okay. So now I have to note down the I have to note down the position of the mirror. It's the around, it's the 62, is the 62. Okay. So pi, so difference between these two, this 62 and this 106, so 107 approximately, 107 and 62. So how much you are getting? 4, 45. So this pi is 45, pi is 45, right. So still you have chance to adjust the mirror, take this mirror position, 2 3 position, okay, 2 3 position, okay, keeping this needle, that one is fixed, okay. So you will get 2 3 value, okay. So you take the average of that one, okay, average of that one. So this way if you can do another, as I told, that you just change the object distance by plus minus 2 centimeters, say change, it is at 20, so keep it at 18, and you have to remove the mirror. Then from the lens you have to find out this position of the image needle, okay, note down the position, then again put the mirror, okay, find out the position for seeing the image at the object position, okay. So that way you can, second observation you can take, and then again you take this, if earlier it was 18, now you put this on a 22, okay, 22, and repeat the experiment. So you can take the third sets of data, and for each set of data, you should take the 2 or 3 data for changing the adjusting the position of the mirror, and then take average of that one, here. So that column is not I have made, but one can made, or just either average you can make here or average you can make here, okay. So that reading, let it be there. Then for second set you take, for third set you take, and then find out the average of that, this mean R basically, and corresponding focal length you will calculate, okay. So this way one has to find out the focal length of the convex mirror, okay. So one has to build up basically skill to see the image position, and how to find this image position. So one has to remove the parallax. That means first what you have to do, this you have image needle, say, and then image, real virtual image you have to see through the mirror or the lens, okay, and you have to change the position of the image needle, and try to find out the position, so that this image tip will come on the tip of the needle, image needle, okay. Now you try to adjust the position of the image needle, so that there will not be any parallax, okay. Parallax means, so if you move your so they will be separated. If you move your eyes, so they will be separated, okay. So if you change the position of the image image needle. So, for a particular position you will see this both are moving same way. Okay. So, that is very important, one has to find out this position, then this experiment are very easy. So, that is the critical to find out this that position. And another thing that about index error I have not discussed. Okay. So, index error basically here whatever index marking is there we are taking this reading. So, but this mark it may not be this whatever the lens we have put here. So, that middle of the lens optical center of the lens may not be this center. Okay. So, and also tip here we are taking tip may not be at this coincide with this mark. Okay. So, that is why that index error generally. So, we take a rod, okay, sharp, two end are sharp, okay, and take the distance of this and this between these two here, okay, and then so what is the distance that rod length. So, that rod length will measure from the scale. So, that whatever the length rod length here we are getting, okay, distance between these two, and whatever here reading we are getting difference of these two reading and this reading here, if both are same then index error is 0. If there is a difference it should be same, if there is a difference plus or minus, so that will be the index error. And when we are taking the reading, so that index error that you have to subtract or add with your reading. So, you have to correct the reading. Okay. So, I assume that this we do not have any index error. So, that is why that part I have not included in the table, but in principle one should check it. So, yes, so basically we have learned that how to measure the focal length of a mirror, that is whether it is convex mirror or it is a concave mirror. So, concave mirror directly you can measure without taking help of convex lens, but for convex mirror directly you cannot measure. So, you have to take help of lens, convex lens, and then you have to measure. So, there is the indirect method. So, I describe both the experiment. Next I will describe how to measure the focal length of a convex lens as well as of a concave lens. Okay. So, let me stop here. Thank you.